Hello students. So today we are going to discuss about the topic redox reactions. Now, as we all know, the topic redox reaction, definitely we need to understand what exactly do we mean by the term redox. Okay? Now, before we start talking about the term redox, let me discuss with you two more important terms before even beginning into this topic. And those two important terms are, first one is the oxidation and the other one is reduction. We have definitely heard about these terms, okay, in our lower grades. No matter if you're talking about Igcse or you're talking about AS levels. So, what do you mean by oxidation? As the name suggests, oxidation is nothing but it is addition of oxygen. But then, guys, if you need to add oxygen, you definitely remove something, okay? Because you need to add oxygen in its place. So, what you would remove if you are adding oxygen, obviously, you would remove from here hydrogen. So, what do you mean by oxidation? It is nothing but addition of oxygen or removal of hydrogen. And obviously, pretty basic. What do you mean by reduction? It's the exact opposite of it. A reduction is nothing but removal of oxygen and addition of hydrogen. Okay, now understand these two definitions that you have written for oxidation and reduction are pretty basic. Okay, even for your 10th grade, 11th grade, these definitions are pretty basic definitions, and we definitely need to understand few more details into oxidation and reduction. Okay, so definitely this thing is true that oxidation is nothing but addition of oxygen, removal of hydrogen. Reduction is nothing but removal of oxygen or addition of hydrogen. But then we also need to understand that oxidation is also the loss of electrons. Okay, please remember, it is very important. So what do you mean by oxidation? The new and the most accurate definition right now is oxidation is nothing but the process in which electrons are lost. And what do you mean by reduction? Then obviously reduction would be nothing but the process in which electrons are gained. So reduction is nothing but gain of electrons. Okay, now how would you remember this? You would remember this by simply remembering a word, oil rig. Okay, you need to remember this word, oil rig. What does oil rig stands for? Oil, that is oxidation, is loss, and rig stands for reduction, is gain. Okay, you need to remember this. Okay, it would be very important for this chapter. So before we begin with what exactly do you mean by redox reaction, once again, what do you mean by oxidation? Oxidation is nothing but the loss of electron. Reduction is nothing but the gain of electron. Let me give you a very simple example. Okay, we have already seen an example of sodium chloride being formed, right? We all know how sodium chloride forms. So what would happen over here? You would have Na, which has a electronic configuration 2, 8, 1, and because he needs to be stable, will he try to lose one electron and get converted to Na positive? The answer is yes. But then in this process, is he losing an electron? Definitely. And because he is losing electron, I could say Na is undergoing a process of oxidation. Okay, now this process we have been learning from pretty long time now. In chemistry, we have been almost, you can say, every lecture we are talking about sodium and chlorine. Okay, that sodium loses one electron, chlorine gains one electron. But then understand, even this process is a process of oxidation and reduction. Similarly, if I talk about chlorine is 2 comma 8 comma 7, would he gain one electron? Definitely yes. And will it get converted to Cl negative? Absolutely. Being converted to Cl negative, you would have the electronic configuration as 2 comma 8 comma 8. Now, is he gaining electron? Yes. And because he is gaining electron, he is undergoing a process of reduction. Okay, so what do you mean by oxidation? Oxidation is nothing but a process in which it is addition of oxygen or removal of hydrogen, or most importantly loss of electrons. Reduction is a process in which electrons are gained. Okay, let's go further. Let's understand few more things into this. Okay, now we talked about sodium and chlorine. Obviously sodium losing one electron, chlorine gaining one electron. So will this happen simultaneously? The answer is yes. Because when sodium would lose an electron, only then chlorine would be able to gain one, right? So when these two processes, that is the process of reduction and the process of oxidation, when it happens simultaneously, the process is known as redox process or redox reactions. Okay, so now comes the definition of our chapter, redox reaction. How would you define redox reactions? Redox reactions are the reactions, reaction in which reduction and oxidation happens simultaneously. So a process in which reduction and oxidation happens simultaneously would be referred as a redox reaction. I hope we are clear with what exactly do you mean by the term redox reactions. Okay, now let's understand. Let's take a few example. Okay, we already know what is oxidation, we already know what is reduction, so I'll just give you a very basic example for now, and then we will discuss more, or we'll discuss about few more good examples. Okay, so let's suppose if I give you a very simple example, let's say you have CuO plus carbon gives Cu plus CO. Now, you could pause this video for some time and try understanding that who is gaining electron and who is losing electron. Okay, so now if I just check over here, copper was earlier with oxygen and now he is without oxygen. So what I can say, CuO is getting converted to copper, whereas carbon is getting converted to carbon monoxide. So copper, who was initially having oxygen, he has lost his oxygen atom, and carbon, who was not having oxygen, has gained oxygen. So once again, what do you mean by the process in which oxygen is lost? The process is referred as reduction. So CuO is undergoing a process of reduction. Please remember, students, it's the entire compound which undergoes the process and not a single atom. You can't say Cu undergoes reduction. You have to say CuO is undergoing reduction. Similarly, carbon is getting converted to carbon monoxide, and therefore we would say that carbon is undergoing the process of oxidation. Why? Because he is gaining oxygen. So carbon over here, he is undergoing a process of oxidation. Now, a very important thing, listen. Could carbon gain oxygen without the presence of CuO? Like, if there was no CuO, or if there was no one to donate oxygen, carbon would remain in its original form. Carbon would remain as carbon. He won't get converted to carbon monoxide or carbon dioxide for that matter. Similarly, because carbon was there to take the oxygen atom, CuO donated its oxygen and got converted to copper. So therefore, what we would say is, we would say that CuO, who is undergoing reduction, is behaving like an oxidizing agent. What is he behaving like? He is behaving like an oxidizing agent. So, why is it behaving like an oxidizing agent? Because he is making it compulsory for carbon to undergo oxidation. Similarly, if I talk about carbon, carbon is undergoing the process of oxidation and therefore he is acting like a reduction agent. Okay, why we can say so? Why carbon is acting like a reducing agent? Because he is forcing copper oxide to undergo the process of reduction. Okay, so over here, what we can remember is, we can remember a very simple rule. Okay, we can just remember the vice versa rule. Okay, or whatever you can say. You can simply remember that a person who undergoes reduction is an oxidizing agent. A person who undergoes oxidation is a reducing agent. Once again, what you will say, a person who is undergoing reduction would be referred as an oxidizing agent. A person who is undergoing oxidation would be referred as a reducing agent. So simple. Okay, you could just remember it's vice versa. If someone is undergoing oxidation, someone will undergo reduction. The person who is undergoing reduction will act as an oxidizing agent. The person who undergoes oxidation would be referred as a reducing agent. Okay, just in case you happen to encounter a question saying define an oxidizing agent, or you happen to encounter a question define a reducing agent, let's see how do you actually define both of them. So over here, what I would say an oxidizing agent, I'll define oxidizing agent first. Okay, so I would say that an oxidizing agent is a substance that undergoes reduction. Okay, because he's an oxidizing agent, he's undergoing reduction. So a substance that undergoes reduction and makes the other species undergo oxidation. So if I am an oxidizing agent, me myself will undergo reduction and I would make the other species undergo oxidation. So similarly, how would you define a reducing agent? I would say a reducing agent is again a substance that undergoes oxidation. Very good, it undergoes oxidation. Okay, because you have to define a reducing agent, it's undergoing oxidation. So a substance that undergoes oxidation and makes the other substance or the other species undergo reduction. Okay, so I hope we are clear with what exactly do you mean by an oxidizing agent, what exactly do you mean by a reducing agent. Similarly, once again, we will just discuss quickly about redox reactions. We said redox reaction is a process in which reduction and oxidation happens simultaneously. What is reduction? Very, very important. Reduction is definitely nothing but loss of electron. Oxidation is nothing but loss of electron and reduction is nothing but the gain of electrons. Similarly, if I just take a very basic example, Na gets converted to Na plus, that reaction is oxidation because Na is losing electron. Let me write it over here. Na is losing electron, whereas chlorine is gaining electron, and because he is gaining electron, this process would be referred as a reduction. Similarly, we took one more example, again a simple example. We are not talking about difficult examples right now. Okay, we'll do it in the next part. So we discussed about a simple reaction. CuO plus C gives Cu plus Co. Over here, CuO was being converted to Cu. That means he is losing oxygen. Carbon, who was alone, gets converted to carbon monoxide. That means he was gaining oxygen. So copper oxide is undergoing reduction. Carbon is undergoing oxidation. A person who undergoes reduction is an oxidizing agent. A person who undergoes oxidation is a reducing agent. We have discussed the definitions. We have written down the definitions. Okay, so that's all for this part. We'll meet in the next part of the chapter where we will talk about few examples. We would also talk about something called as valencies and oxidation numbers. Till then, thank you so much.